Okay, this is your favorite Algebra 2 teacher coming back at you with some more videos. And today we're going to do adding and subtracting rational, which is another word for what? Thought I didn't hear it, so that's fraction. Expressions, okay? And that's what we're going to be learning about. I know you just did multiplying, simplifying, but now we're going to do adding and subtracting. All right, so let's see what we can get on with here. All right, so now in order to add and subtract, you know, if I gave you something like, you remember we always had to have a warm-up. I just started, I know the last day before we got out, but anyway, so here's my warm-up right here. So the good thing about this is you got a common denominator. So most of y'all know when you got a common denominator that 2 plus 4 used to be 6. So it's just going to be 6 over 7. Those are easy, okay? So if I gave you something simple like 6x over x plus 2 plus 4x minus 5. That's a minus in case you didn't know that. And that's x plus 2. Okay, it's the same just like the one above. I have a common denominator, so all you do is just add the tops, which is basically what's going to happen here. We have a common denominator. We're going to keep that thing, and then we're going to combine the top. So be careful. Make sure you see if I'm doing plus or minus. I'm doing 6x plus 4x minus 5. The bottom you're going to leave as x plus 2. That's your common denominator. The top, you do need to combine your like terms. So 6x plus 4x used to be 10x, not squared because you're not multiplying. And that's going to be minus 5. Now, that is going to be your final answer. However, I will tell you, if we were still in class, I'd probably make you change that a smidgen. But since we're not, we're going to leave it like that. Okay, that's your first example. When you already have a common denominator, should be super easy. Okay, all right, good. Let's take a look at another one. Let's suppose I have get one like this, which is, let's see, like this. So I need a common denominator to add them together, but you can tell that obviously they aren't the same, but you want to make them be the same if possible, which it is going to be possible, or we wouldn't be doing this. So, so the deal is when I look at this, I see I have an X, and that one does not have an X. So what I'm going to do is I am going to multiply this one by X, and whatever I put on the bottom, you got to put it on the top. So now I have an X on both. Now, so the next thing you're thinking, well, can I make 5 become a 10? And you said, well, why, yes, I could add 5. Well, yes, you could, but that's not what we're going to do. We're going to multiply by 2 on the top and the bottom. So when you multiply, that's going to give you 10x, and then that's going to be 10x. So basically, you have a common denominator of what? That's 10x. Very good. And then, so now at the top, I've got 2 times 3 used to be 6, plus 1 times x is 1x, or just x. And can you add 6 plus x? No, but we're going to leave it side by side over 10x. So I told y'all the other day, or either wrote it on one of those papers, I don't remember which one, but you can't subtract, you can't reduce the x's, because this one has a plus with it, and that one does not. Okay, so therefore that's going to be your final answer. Now, so the deal is I'm going to do about 4 more examples here. And now actually, just kidding. I'm going to do 3 more examples. Okay, so now, but remember, every example I do, I'm not doing examples just so I can make this video be 10 minutes, because in fact, I like for it to be less than 10 minutes, and I'm a little worried that this one's going to be longer. So every example I'm doing has to do with one that you might see, and they're all a smidgen different, okay? So if you're getting bored, remember, each new problem is a new thing. So when I look at this one's pretty easy. Are these the same? Absolutely not. Do I need to make the 5 or the 3 be like each other? No. This is a whole unit, and this is a whole unit. So really what you're going to do is you're going to take, I need to make, if this one is an x plus 5, it needs to have whatever this one has, which is an x plus 3. So that means, let's see if I can do this right there, and lo and behold, I think I can. Yes, I changed the color. All right, so that's going to be x plus 3. I'm getting better with this. Man, by the time we get through this distance learning, I probably am going to retire and just do videos. So now I've got x plus 5 and x plus 3. Whatever I put on the bottom, you have to put it on the top. So when I go over to the second fraction, I've got x plus 3. So what do I need with it that the first one has? I thought I heard somebody say it. X plus 5. Good. So x plus 5, whatever you put on the bottom, you got to put it on the top. Okay, so now if you go back and you look, you'll see that these are exactly the same. They have the same denominator now. So what is my common denominator? It's x plus 5. Hope y'all can see that green. If not, just tell me. Anybody can't see the green? All right, good. I didn't think I could hear anybody. So I'm going to keep that as my common denominator, and then we're going to work with the top. Be sure you see right here, this time I tricked you with a minus. So we've got 4x, x plus 2, minus 8 with an x plus 5. Now, you don't have to rewrite that, but I am, so you can see I've got my common denominator, and these are my numerators that we're going to have to distribute and combine like terms. So I'm on my top here. That's going to give me 4x squared. That's going to give me an 8x, 4x times 2. And then be careful here. That's not just 8, but that's going to be 8x. I mean, just kidding. I didn't mean to say that. You heard me wrong. That's negative 8 that you're going to be distributing here and here. So be careful with your signs. So negative 8 times x is negative 8x. And negative 8 times 5 is negative 40. That's my numerator. Still got my common denominator. And some video I watched said they wanted you to multiply these back out together. I do not. I told y'all I wanted you, that's fine to leave it separate. And you can, because most of the time that's what will happen. Let's look at the top and clean it up some. All right, so there is the 4x squared. There's not another like term. This is 8x minus 8x. What happens with that? Goes away. Should I put plus x? No. Why not? Because that means we've got 1. We don't have we have no x's left, so that's 0x. You can put 0x, but I wouldn't advise it. And then you got minus 40. And then over the common denominator, which is this right here. Okay? So, and that's going to be our answer. This is another one. I'm going to be honest. If we were in class, I wouldn't let you leave it like that, because does anybody recognize what's going on the top? Because usually you don't leave it, like kind of like we left the bottom in factored form. You kind of usually leave the top in factored form. Anybody see what kind of something we could do on top? Yes, I thought I heard it. You could take out a 4. You could take out 4. That would be x squared minus 10. Now, I asked y'all, could this be the difference of 2 squares the other day? And y'all told me no, because 10 is not a perfect square. And you had the right on the money answer. All right. And then you have x plus 5 over x plus 3. So, to be honest, if we were still in class, this is what I would have you do for sure. But to be honest, if you can get it to this right there, I'll be proud. If you do this one, I'll probably know you just cheated. However, this is the one I'm looking for right there. Okay, that's my final. If you can get it to that point right here, I'll be good. All right. So I told y'all I had, let's see, 3 more examples. That was 1. That means I got 2 more. Anybody remember that? All right, good. So let's change. I don't like this color though. Let's change it. Let's go back to the red. Okay. So I'm going to do 5x over x squared minus 16 plus 2 over x minus 4. Okay. All right. So now when I look at this, okay, I'm thinking I need for them to look the same. So on this problem right here, remember every problem's different. On the problems before, there really wasn't any factoring to be done. And so to be honest, I should have said, is there anything that we can factor, ladies and gentlemen? And you would have said no. But since you and I both could see that there wasn't anything to factor, I didn't even go there. But when I look at this, I know, because y'all are smart, that this right here is screaming at me. What's it screaming? The difference of two squares. Yes, it is. So that's going to be 5x over x minus 4 and x plus 4. Okay? All right, so now we got this going on. And then over here, let's see. Can I factor that? Why? No, I can't. Because some of you are thinking, that's the difference of two squares. And no, it's not. Why is it not the difference of two squares, ladies and gentlemen? Because this right here is not squared. So therefore, that is just x minus 4 over 2, okay? So the first thing I've done is I have factored. That's the first thing you need to do, okay? So now you're looking at this bottom, this denominator, and this denominator. I need them to be the same. So does this one have, how can I make them be the same? How can I make them be the same? Oh, if that one was just over here too, they would be the same. Okay, well, good. We're going to do that. All right, so now I'm getting better with this pen situation here. And so that means I'm going to put the x plus 4 here. I'm going to put parentheses around that one. And then remember, whatever I put on the bottom, I need to put it on the top. Why is that? Because like I told y'all before when you weren't listening earlier this year, that if you, because technically that means you can mark that out. That's like a 1. And so you're really multiplying by 1, which doesn't change the value. It just changes the look, okay? So here is, so now if you go back, these denominators are exactly the same. So that means we're going to work with my common denominator, which is x minus 4 and x plus 4. And now we're going to work with the top. So we got 5x plus 2. I'm just going to rewrite the tops every time just like I have it. So therefore you'll know exactly where I'm getting everything from. Now, on the bottom, I'm going to keep my common denominator as factors. Do not have to multiply it back out. On the top, though, I need to clean it up, okay? So I'm going to have 5x, distribute the 2. This time you're distributing a positive 2. So you're going to do 2x. 2 times 4 is going to give me an 8 usually. And so now still got one more step. 5x plus 2x used to give me 7x. And I got plus 8. That's over x minus 4, x plus 4. All right. And on the top, this one for real is for really done because there's nothing to factor at all on the top. So that would be my final answer. Anybody got any questions? I didn't think I heard them. All right, so good. Everybody's clear as mud. All right, so next one. In fact, this might be the last one. And so somebody in the class, please help me remember. There's a couple of announcements I meant to do at the beginning of this video, and I forgot. So I need you to make sure that you help me to remember to go over a couple of announcements at the end of this video from last week. All right, so let's take a look at this. All right, so when I got, you'll notice we're going to subtract here. We need a common denominator. Common denominator. Well, so the first thing, what do we need to do first? We need to factor the denominators. Factor the denominator. So when I look at this, what type is that? Y'all should kind of know what the type is by now. Because as I told y'all, if you hadn't learned it by now, after all these lessons, I told you was going to have to know how to factor in order to get by with this. And to get by with this, you could tell if we were in school, boy howdy, you'd be doing some major factoring going on. So x squared plus 7x plus 12, that's a trinomial. Remember, on the trinomial, you're saying what are factors of 12, positive 12, that'll give me a 7. Ooh, what in the world happened there? Okay, so that's better now. So that's going to be, so factors of 12. Factors of 12, don't forget the obvious, 1 and 12, 2 and 6, and 3 and 4. Which pair will give me the 7? Obviously, that is the 3 and the 4. And I want a positive 7, so I need a positive 3, a positive 4. Check yourself. Does 3 and 4 combine? to give me a positive 7? Yes. Do they multiply to give me a positive 12? Yes, they do. So that one's factored. Oh, forgot the x right there. All right. So on the second fraction here, I got 5x plus 15. So what kind of factoring do you see there? Obviously, it's not a trinomial. Obviously, for more than one reason, it's not the difference of two squares. And by the way, I don't know if y'all have noticed, but I've tried not to kill you. And on none of these so far have I done the sum or difference of two cubes. I did want to throw it out there last week because I know it's important for some of you who might want to go on to do math beyond me. So, but some of you aspire to go to college. So, I got 5x plus 15. What is, I see we have a common factor of 5. Not 5x, just 5. So, I'm going to take out 5 from both of those. So, I'm going to put the 5 out front as my greatest common factor. That means I got x plus 15 divided by 5 is 3. So, this is what I've got. All right, so these are my denominators now. And I'm going to bring down the 6x and the 7. So the first thing is, so now the second step is we need to make all these denominators be the same. So let's look here and let's look here and compare them. Okay, so what does this one not have that this one has? Good, the 5. I thought I heard it. So that means I'm going to put, hold on, let me use a little different color. And that's going to be right here. So I'm going to put me I'm going to stick me a 5 here, which means I'm going to stick me a 5 here. Okay, remember, whatever you put on the bottom, you got to put on the top. So now if I come over here to this second fraction, what is this one missing that the first one has? Okay, so you see that we have 5. We have x plus 3. So this one here needs, what does it need? It needs the x plus 4. So whatever I put on the bottom, where else do you put it? Correct, on the top. So there we go. So our common denominator, ladies and gentlemen, boys and girls, children of all ages and shoe sizes, is going to be x plus 3 and 5. Oh, I forgot to say it. 5, x plus 3, and x plus 4. That's my common denominator. So now on the top, I'm going to have 5 times 6x minus, make sure you see that that was a minus there. That's important. And that's going to be 7 and x plus 4. Again, some of you can leave out that step right there, but for probably 10 out of 80 y'all probably need to put it in because you're going to get tripped up with your signs. So that means on the top, let's finish cleaning it up. So that's going to be 5 times 6, which is 30x. Now, be careful right here. That's negative 7, which is going to be negative 7x. And negative 7 times 4, which is going to be a negative 28. That's all over 5, x plus 3, x plus 4. All right, very good. All right, got any like terms on top? Sure do. So 30 minus 7 is going to be 23x minus 28. All right, and then all over common denominator. Again, leave them as factors. If you watch a video other than mine, shame on you. But if you do, that's fine. And they multiply them together, you're doing more work than you need to. 9 times out of 7, you usually leave them in factored form. And on the top, I'd factor it too, but there's nothing in common between 28 and 23. So therefore, ladies and gentlemen, boys and girls, children of all ages and shoe sizes, this is my final answer. So basically, you got to, first step, you got to factor if possible. Then you got to make the common denominator. Get a common denominator. All right. So now I am done with all of this. I don't know how long this video is. However, and it's probably getting long, but I know that y'all have missed hearing me. And I've missed hearing y'all too. So, well, actually, no, some of y'all have missed. No, just kidding. I've missed most of y'all. So, but there's a couple of problems on last week. Believe it or not, and I know somebody's like, she ain't looking at all those problems she been giving us. Yes, I do. Because when I email you back and say, you didn't do this or you didn't do this, you know that I'm looking at them. And so this question the other week, and I asked the question, this was on the greatest common factor problem. You might remember it. And, it was something like this. And I said, was this problem correct for factoring the greatest common factor? Now, some of you got it right, and some of you didn't. So that's why I'm going back and addressing it, okay? And I'm going to email it to you. No, the deal is that this here is, you did take out, because most of you said, some of you said, no, it was not right. And to be honest, no, it's not right. But the deal is, some of you said it was right because if you distributed it, you get back the same thing, which you are correct in saying that. But the deal is, if you look at 12 and 16, the deal is you wanted the greatest common factor. So the greatest common factor means you want the greatest number that'll go into 12 and 16, which is not 2. Some of y'all called it, some of you didn't. So the deal is, it should have been 4x as the greatest common factor, which would end up giving you 3x plus 4. It's not a huge deal if you're multiplying it back out like y'all told me. You can see where, if you're doing the problems we're doing now and you're trying to get a common denominator, or if you're doing those multiplying problems where you got to factor all that junk and reduce them, then you would see where might present a problem. So just wanted to make sure you knew about that. I didn't give you a 50. I at least gave you a 60 if you got it wrong. And so just wanted to clarify that. Another thing I wanted to clarify was one of the answers, not problems, on the simplifying radicals last week. One of the answers, some of you left like this. And to be honest, I'm going to say, if you left it like that, I was really almost proud, because that means you didn't just cheat. Because the computer or anything else would have told you something differently. And so the deal is, let me first make note of this. Sometimes it's better to understand something when you hear somebody instead of just seeing it written. This and this are two different problems. Okay, the difference, obviously they're different. The plus makes a huge difference right there. Okay, on the top, when there is not a plus sign, the 3's will actually cancel. So last week, if you left your answer as that, I was proud, because that means I knew you earnestly worked. However, I just want to make sure you know and realize, in case you, since you might not have, is that the 3's will actually reduce. Now, does that mean your answer is X? Where is the X in this problem? It's in the denominator, so it needs to be 1 over X. Should have been your final answer. Again, I didn't count it wrong. I only counted off about 15 points. No, just kidding. I didn't count off anything. Again, I told you I was proud. If you got it to this point, I was proud. But now, if you had a problem like this one right here, you cannot mark out. So you cannot mark out the 3's, because that plus 3 makes it different. It's like a unit. You can't mark it out. So 3 over 3x does become 1 over x. However, 3 over x plus 3 stays 3 over x plus 3. You cannot mark out the 3's. This and this would be your final answer. And I think that might be the end of my announcements. I hope you have enjoyed the video. Like me on Facebook. No, just kidding. I don't do Facebook. I ain't got time for it. But I'm hoping to I like doing my videos, because at least I know I say what I want you to hear. And I'm hoping that all of you are staying safe. Wash your hands. Stay 6 feet apart. Stay out of my face. And keep on distance learning. I miss having y'all. I miss doing all my jokes with y'all. But until next week, guess what? We are still factoring, yes. So then we're going to do equations. So I miss y'all, love y'all, stay safe, and have a great week.